In this video, I want to talk about computational thinking and how it can make you not just a better data journalist, but a better journalist more generally. I'm going to talk about how functions are a particularly good example of the role of computational thinking and how it can be used with it. And finally, I'm going to also problematize this a little bit and bring some critical thinking into it. So, computational thinking is a term that was popularised by a woman called Jeanette Wing. Jeanette was not a journalist, she was interested in computer science, but what she saw was that there was a certain literacy that you needed to be able to work with computers, which was a literacy just as important as being able to read or being able to work with numbers. And she talks about thinking like a computer scientist being more than just being able to program a computer. So it's not just the technical skills. In fact, this isn't really about the technical skills. It's about thinking at multiple levels of abstraction. And in particular, computational thinking is often talked about in relation to four different things. Decomposition of particular problems, the abstraction of certain parts of that, the ability to recognize patterns, and the ability to create algorithms. Now, again, I want to emphasize that these are not technical skills. So when we talk about algorithms, we do not necessarily mean the technical skills to create an algorithm. What we mean is the ability to write a series of instructions, and that might be with pen and paper. I'm going to go through each of these in turn, beginning with decomposition, and I'm going to relate them to journalism. Now, Adrian Holovaty is one of the pioneers of data journalism. He created some of the seminal works in its early days, and he's had a massive influence on the practice. In 2016, he wrote a very influential blog post called "A Fundamental Way Newspaper Sites Need to Change," and you should definitely read that this week. It's not a long blog post, but in that blog post, what Adrian Holovaty does is essentially a process of decomposition. He looks at newspaper websites and newspaper articles, and he starts to break apart the different elements that stories have. So he points out that an obituary is about a person. It involves dates. It has funeral homes. So these are the properties involved, the entities involved in that story. Likewise, a very routine wedding announcement has similar properties that we can identify and break apart, decompose. Now, what Adrian was arguing is that the practice of manually writing these updates, these very basic notices, was very routine, and in fact perhaps should be automated instead. And as journalists, perhaps we should be thinking of the bigger picture, thinking about, well, if we did this in a structured way, what could we say about obituaries, deaths, births, weddings in general? And this approach, as I said, was hugely influential, and it's led to what's now called structured journalism. Structured journalism is the practice of building a structured data set and using that to create editorial products. Politifact is a particularly good example of this. In his books Apostles of Uncertainty, C.W. Anderson devotes quite a lot of time to Politifact, and he talks about how the project first created a database of political statements, which could then be used to generate stories and other output, and then it would use that database to create various narratives. So this idea of having a database which powers your storytelling is really what we're talking about here. And in order to do that, we need to decompose the elements of our stories and store that in ways that we can create many different stories from them, both short-term and long-term. Moving on to abstraction then, where does abstraction come into journalism? To illustrate this, I want to use a story that BuzzFeed did a few years ago on match fixing in tennis. And this is a really good example of abstraction as an important part of the journalistic process. Imagine that you're John Templin and you've been given a tip-off, or you have a suspicion that match fixing is taking place in tennis. The question you ask yourself as a data journalist is, what data might there be that allows me to establish the truth or not of this tip-off? Now, the very literal data might be documents saying that match fixing is taking place, or leaks, taped conversations from people fixing matches, that sort of thing. But that's not abstraction, that's literally evidence of what's happening. In this case, that evidence is not available. So we need to think, well, what other signals might there be of this behaviour, of match fixing behaviour? So that's what I'd like you to do now. Just pause this video for about a minute or so and just have a think, write down about what types of data might be evidence of match fixing. Try and abstract the problem. Okay, so hopefully you've paused the video for a while and you've had a think about how you might do this. You might have had no ideas. You might have thought that perhaps the betting companies might have data about the amounts of bets placed on these matches, because that's going to be some sort of evidence perhaps that match fixing is taking place. To abstract this problem, what we need to think about is, well, why is match fixing why does it take place? It takes place because people make money from it by betting on the matches that they know are going to have a particular result, and they bet large amounts of money, otherwise it's not worth it. There will be money spent to fix the matches, so we need to recoup that money. Now, the obvious evidence of large amounts of money being bet on matches is data about the bets being placed. So that might be one level of abstraction. Again, it's not particularly abstract, it's quite literal, but we are getting further away from very obvious evidence. But let's assume that the betting companies are not willing to share with us data about large bets being placed on tennis matches. Can we abstract this further? Well, if large bets are being placed on matches, what other data might that generate? Well, first of all, that's going to affect the odds. So if large bets are being placed, the odds are going to be adjusted so that the bookmakers are not going to lose too much money if the result goes a particular way. So perhaps one piece of evidence might be large changes in the odds around matches. That's one of the things that John looked at. The other piece of evidence might be the match results themselves. You may have thought of this yourself. So, are we getting results that are unlike what we might expect? Are we getting those for a particular player more than other players? And that's the second ingredient of the story that John used. So he took data on odds and looked for large swings in odds around matches, and he took data around match results and looked for unusual results. So that's a good example of abstraction and how it can help in journalism. I now want to move on to the third part, which is pattern recognition. Now, pattern recognition is extremely useful in data journalism. It helps us to recognize data itself, and it's worth emphasizing that it helps us solve problems as well in our spreadsheets. One of the types of pattern recognition that you should be looking for in spreadsheets is whether data is numerical or text-based. One pattern you might notice is that numbers tend to be aligned right in a spreadsheet, whereas text tends to be aligned left. Now, that alignment by Excel is a process of, it's a pattern that it imposes on the data, and it allows us to visually see whether the data is what we think it is. So if we see something that might look like a number but it's left aligned, we should be alert to that and spot that pattern and realize that actually that means it's being treated as text by Excel. It might be treated as text because it's got currency signs or spaces or something else in it. Dates are a classic example of this. Dates should be treated as numbers. We should be able to sort them to calculate differences, and so dates should be aligned to the right in spreadsheets. But if you see a date that's aligned to the left, it's probably been brought in as a series of characters and treated as text instead, which means you can't perform all sorts of calculations with it, and you probably need to clean it up. Another pattern to look for is in the way that formulas are written in spreadsheets. You should notice that a formula always begins with an equal sign, and that's only used once right at the start. You should also notice that any words in a formula are followed by brackets. These are called functions, and we'll come on to them later on. You might notice that inside those brackets, each separate part, if there's more than one part, has a comma between them or a semicolon, depending on the language of your spreadsheet tool. So those are just some examples of pattern recognition within the spreadsheet itself that can help you spot problems and solve them. But you can also use them when looking for stories. So here, for example, is a page from sheetmusic.com. A good data journalist might be looking at this page and notice some patterns that allow them to come up with story ideas. So again, have a look at that for a while and have a think if there are particular patterns that give you ideas for stories. Patterns are essentially data. So what data, what patterns might there be on this page? Well, we can see a table, for example, where it says quick details, and we can see that there is some structure and some patterns there, and if we look at other pages we will see the same pattern. We might see that certain characters always separate the instruments, for example, and the vocal range. We can look for that pattern in the HTML as well. It's always worth looking at the HTML underpinning a page and seeing if there are other patterns that might be helpful that aren't visible purely from the text on the page. So this is the HTML underpinning the same page, and we can see the bit where it says voice, range F#3 to C#5. Now there's some other information here. So there's an image link. There's an alt tag, alt equals voice range, etc. There's a label class above that, and so on. So this is extra information in the code that we might look for as well if we were trying to grab this information. And finally, there's the URL as well. URLs are often full of patterns. In this case, we've got this ppn equals mn followed by a series of numbers. That looks like a possible pattern. If we look at some other pages for other sheet music, we might notice that this code has certain patterns. Maybe it's always 2 letters followed by 7 numbers. Maybe it's not. Maybe it's different. And the pattern of a URL is something to look for as a data journalist as well. And again, these aren't technical skills. These are about spotting opportunities. You might work with someone else to grab this information in this HTML or on this page, but the point is that you can see that pattern and see the opportunity. Finally then, the final part of computational thinking is algorithms. And algorithms are something you encounter in functions that you use in spreadsheets. A function is basically a recipe that allows you to perform some sort of action in a spreadsheet. So for example, sum is a function that will add up a series of numbers. Average is a function that will calculate an average for a series of numbers, and so on. Each of these words essentially represents a recipe. So the function sum, what's the series of steps? What's the recipe here? What sum says basically is, if you give me a range of cells or a range of numbers, I will add up the numbers in those cells and I will give you a total of all those numbers. Very straightforward. It's a series of steps, but it's quicker than you manually typing each of those steps. That those series of steps has been encoded in an algorithm, a recipe. Average is a little bit more complicated. What that says is add up all the values in a series of cells, but then also count how many numerical cells there are and divide the total by that number of cells. Now notice it's only going to divide it by the number of cells containing numbers, so it does need to also work out how many cells contain numbers. The third one, median, will work slightly different. It will say take all the numbers in that range of cells, order them from smallest to largest, and then identify the number that's in the middle or the number between the two numbers in the middle, if there is no middle number. Count will count how many numerical cells there are in that range. And then you have functions that take more than one ingredient. Those first four all take just one ingredient. But SUMIF is a function that needs two ingredients. It needs a range of cells, but it also needs a condition. So it will, in this particular case, it's going to look at all the numbers between A2 and A30, and if those numbers, or each of those numbers, is above 10, it will include that number in the sum. So in other words, if it finds any numbers in that range that are lower than 10, that particular number will not be included in the sum. It will only add up numbers that are higher than 10. So more complex functions have multiple ingredients separated by commas. But a few things to point out about these functions. First of all, it's always a word. Secondly, it's always followed by brackets, even if those brackets are empty. Some functions use empty brackets, but they still use brackets. And thirdly, a function always has ingredients, or it tends to have ingredients in those brackets, and if it has more than one ingredient, those are separated by a comma or a semicolon if you're using a non-English version of Excel or Google Sheets. So let me give you an example of these techniques in practice. Let's say I've got some data with a column of phone numbers and I want to extract the area codes from those phone numbers. I want to know which areas appear most often. So I might start with some pattern recognition. I can notice a pattern that the phone number is always in two parts. I might notice that the second part is always 7 digits, whereas the first part varies in length. I'm starting now to abstract the problem in terms of which parts I need to solve. So what do I need to do? I need to extract that first part of the phone number before those 7 digits. Now that allows me to create an algorithm, a series of steps. Step 1, get rid of those 7 digits. Step 2, keep what's left. Quite a simple one, but we've got that process of pattern recognition, abstraction, algorithm, and so on. You can create algorithms yourself by starting to nest different formulae, different functions inside each other. This particular example, I don't want you to worry about the formula here because it's quite intimidating if you're just coming at it without having written it yourself. But I just want to give it as an example in terms of the different steps that are in this formula. So step 1 of this formula is that it measures the length of what's in cell A2. Step 2 is that it subtracts 7 from that number, from the length. And step 3 is that it grabs that many characters, the number that we're left with, from cell A2, starting from the left. So this, for example, is an algorithm, a formula, which would extract the area code of a phone number. Again, don't worry about the particular formula. I just want to illustrate that this is a series of steps that have been essentially encoded in a formula. Another formula to show you is an example of using the function if. Now the if function in Excel is essentially a way of creating an algorithm without having to nest different functions within each other. And the if function needs 3 ingredients. The first ingredient is some sort of test, so some sort of condition that can be true or false. The second ingredient is what action you want it to take if it's true, and the third ingredient is what action you want it to take if it's not true, if it's false. So in this example, the test is A2 bigger than B2? So A2 greater than B2, that's the test. If that's true, if A2 is bigger than 2, then it will perform the first action. It will use the text, first cell is bigger, and put that in the cell where you've typed this formula. If that's not true, it will perform the second action, which is the text first cell is not bigger, so it will put that text in this cell. If else, which is what this is called, is used in coding as well, and we'll come on to coding in future weeks. But I just want to mention that this function, if, is basically a way of doing a little bit of coding in Excel. In R, it looks like the code at the top. In Python, it looks like the code at the bottom. Also, the code at the top is, I think, how it looks in JavaScript. So the structure is quite similar. We've got if followed by a condition, followed by the first action. What's slightly different here is we've also got the word else, and that comes before the second action. But again, pattern recognition, we're looking at a similar pattern here. An if followed by a condition, followed by an action, followed by a second action. And you can actually have multiple actions in coding. Finally then, I've outlined those four parts of computational thinking, but I want to return again to decomposition to emphasize the role of trial and error in all of this. Trial and error is absolutely fundamental to how you approach problems in data journalism. And if you come from a humanities background, if you're used to learning subjects like history or English, things like that, you may be used to a different way of learning to the way that you would approach stories as a data journalist. So you might read a book from beginning to end. You might learn things and then demonstrate what you have learned in terms of your knowledge. When it comes to computational thinking, that's not necessarily going to be the case. What you would do instead, for example, is you might try different approaches, get it wrong, and then work out why it's gone wrong. You might not read a book about coding or about Excel from start to end. You might dip into different chapters to solve different problems. And again, this is an example of decomposition. What you're doing here is you're breaking down a problem, a challenge, into different problems. Some of them will be successful, so some parts of your attempts will work and some of them will not. So through trial and error, you will identify the bits that do work and the bits that don't. The bits that don't work, you will then focus on and try to solve on their own. So you will decompose your challenge into a series of problems to try and solve through trial and error. So that's computational thinking. I said I would also problematize this right at the end, and so that's what I want to do here. As we've gone through this process of starting to look at data and look at indeed the world in a way that involves pattern recognition, involves algorithms, things like that, as we start to solve problems in that way, it's worth thinking about the fact that this is how the world, if you like, works increasingly more broadly. So increasingly people and their actions and their behavior has to be put in a shape that computers can work with. So this is the transformation of knowledge into information. And that can have side effects, that can have negative side effects, which as journalists we need to be aware of. Partly because it will affect the data that we're working with. We always need to bear in mind that data has been treated in a certain way to make it fit into the boxes that it needs to fit into. So we need to have that skepticism and think about how it might have arrived at that point and if that might have caused problems. Likewise, we need to think about our own processes as we do the same thing. We may take information, transform it into data, and that might involve information being left out, for example, or being fit into particular categories that may not be entirely appropriate. So do problematize your own processes and the processes that create the data that you're working with. Sometimes that can be the story itself. Increasingly, algorithmic accountability is the field of looking at how algorithms are affecting people's lives and essentially making mistakes. So, just to summarize what we've covered in this video, first of all, use that computational approach, computational thinking, to break stories down into different problems to solve. Each of those problems will likely be a different stage in your journalistic process. Some of those problems may not be computational. They might be things like getting interviews or visiting a particular event. Secondly, try to look at data like a computer does. For example, if you see a word in data, remember that to a computer it's not a word, it has no meaning, it's just a series of characters. So two words that mean the same thing to you will be seen completely differently by a computer. Even something like a space or a currency symbol can change how a computer sees something, and indeed it will not see two things as the same if there's any sort of difference in terms of the characters. Dates are a particular good example of this. Dates should be numerical, and they just are formatted to look like a date, and that's how the computer sees it. You might see a date, but the computer needs to understand it numerically in order to perform certain calculations with it. And finally, remember that functions are your first introduction to algorithms. They are recipes for performing a series of actions with the data that you're working with, whether that's text data or numerical or true and false values. And you can make your own functions through using the if, your own algorithms, I should say, using the if function in Excel. You can also use nesting to combine different functions into a formula that is essentially an algorithm. And when you move on to coding, you can write your own functions, your own algorithms, using languages like R and Python and JavaScript. A couple of things then to look ahead. First of all, in the repo for this module for this week, you will find a series of computational thinking challenges, one of which is the postcode challenge. How do you extract a postcode district from a full postcode? And secondly, it's well worth watching a video by Nicholas Diakopoulos on computational thinking, which is in the slides for this presentation. And in that video, Nicholas Diakopoulos talks about how computational thinking plays a role in the news industry more generally, so looking at things like automation, and he goes into more depth on some of the different aspects that can be considered as part of computational thinking. So do go and watch that and have a play with the tasks in the repo, and I'll see you in class.